Hello friends, welcome to my Hariharan Express channel. Today I will discuss another topic, flow chart of instruction cycle. Today another topic I will discuss, that is flow chart of instruction cycle. Okay. Previously we have already discussed that is a instruction cycle having different phases. Okay. When different phases used to assess the instruction and that is execute, how it will execute, before execution how instruction will be that is processed. Okay, what are the concept of what are the process of different instruction using different phases, that kind of things we have already discussed in instruction cycle. But today I will discuss regarding on instruction cycle through some certain flow chart. Flow chart is required because we can identify with a different kind of instruction flow of instructions as per the time slot. Whenever you go through different time, then how it is defined through the different kind of instruction. Whenever time we will consider, then how it is defined. Okay. First of all, we will see that what are the instruction or how instruction will fetch or how instruction will retrieve from memory and how it will execute through certain phases. So normally we know that 4 phases are used for execution of any kind of instruction. So whenever any instruction fetches from memory, again used for instruction used for execution, then different phases are required as per the time slot. So we can see different time slots are there, then how it will that is assess the instruction and prepare for execution. Okay, some certain that is instruction will take and we'll see that how it is defined through time. Okay, let us consider that is 3 times we will consider t0 time AR. We have already discussed this, but still that is I will repeat. That is initially program counter select the particular instruction and transfer to AR register, that is address register. And t2 time t1 time, and then on t1 time what happens, that particular address register collect from memory. Okay, collect from memory, address register collect from memory and transfer to instruction register. That means instruction register receive the particular data from memory, where it will receive through address register. Okay, address register transfer the instruction to the instruction register, because here address register gives the address of a particular instruction. Then after that from memory, actually address register gives the address of particular instruction in memory. Then whenever time slot is particular t1 time will come, then it will transfer to instruction register. And at that time whenever transfer the instruction to the register, again PC will be increased. PC will be increased. Next, that means it is ready for next instruction. After getting the getting the instruction at instruction register, then t2 time that instruction need to decode. So in that case what happens, number of decode are there, d0 d1 up to d7, that is 8 number of decode of a particular instruction. That means opcode part need to decode. So what happens, whenever decode, that is opcode part decode in this way, like a decode of IR. Okay, decode of IR, that is 12 to 14, because this is the operation part that we can tell as opcode. Symbolically you can write opcode part of instruction, that is 12 to 14, that is 3 digits you can create. So if 3 digits, that 2 to the 3, 8 decodes, 8 number of decodes we can create, d0 to d7. and during that time then what happens in the T2 time, again other part also, that is a transfer here, since address register give the address of our data. So here what happens, IR, that is 0 to 11, because address part that is 0 to 11, that address part of data or operand that transfer to address register. This is the another concept. And during that time period also IE, that is mode, receive the 15 data, 15 bits I mode. Okay, that data also received by the mode. Okay, this is the basic instruction. Whenever we need to start any execution, before that we will, that is go through this kind of a time slot for processing our instruction. So first case what happens, fetch an instruction from memory. Okay, that means like this PC just count to the particular instruction from memory, and that is also transferred to memory and it is assigned to instruction register. Next, after that, whenever instruction register ready or know that what is the instruction, then it start the decode. So decode the instruction is the second page. And next, read the effective address from memory if the instruction has been indirect address. And lastly, we will execute that instruction. Normally the 4 phases whenever we consider. Okay, so when go through these different phases, so it different time slots also required. Okay, now we see how it is that is a decode, or that is what are the flow chart is required to define or to explain or to process this kind of instruction as per this time slot. Okay, so here you see very simple, it actually depend on this particular D7, D0 to D6 is defined for that is some memory. D7 actually defined for other references. So different references we can consider, either the data collect from register, or data collect from memory, or data collect from, or operation, particular operation and data also collect from input output register. So whenever it is defined, it depend on the D7 only. Okay, D7, if D7 is 0, then what happens, it identify the particular operation need to use, that is a memory reference. If D0 is equal to 0, D7 is equal to 0, then it will consider that is a memory reference. Memory reference. In this way, we can create that particular flow chart or flow chart. Now, if D7 is equal to 1, then what happens? It use, that is either register or input output reference, in register in reference or input output reference. Whenever I go through register, how to know that it is a register or input output in reference? And again it depend on the, that is a mode. If mode is equal to 0, then it will go through register. Okay, D7 is 1, again it will depend on the mode. If I is equal to 0, then go through, that is a register. Okay, if I is equal to 1, then go to input output reference. Okay, so in this way we can define either a memory reference or a register reference or input output reference. It absolutely depend on this D7. This D7 is a decoding part of this. Okay, so now we will see how to define that particular or design particular flow chart of instruction cycle. It is actually defined through D7 only. Symbolically we can also do different kind of things. Now we will see, we start our, that is work, how it is defined as per this time slot, that is T0, T1, T2. Okay, that based on that inputs we will see that how it will be designed. Okay, now we see, I just draw this particular flow chart of this that design regarding on that flow chart of instruction cycle in this way. Okay, very simply, initially that is start is equal to SC is equal to 0, means sequence, SC for sequence counter. You see, SC is a sequence counter. Sequence counter used for time only. Whenever a time slot timing is increasing, time is increasing 0, 1, 2, 3, 4 like this, then a sequence counter will consider. Sequence counter used for that is time. So start time 0, that is sequence control, it is 0. Now T0, so T0, then what happens? As per this particular problem, what I already mentioned here, you see, if T0, then what happens? PC is transferred to AR, means PC assigned to one instruction that transfer to AR, means AR register receive that PC. PC means it is the address register. Address register is receive the that instruction register which is transferred to memory. Okay, this is the first T0 time. Here I say very simple way, T0 time what happens? AR receive the that is instruction from PC, where PC kept one instruction. Okay, after that what happens? T1, whenever T1 start, then what happens? AR actually linked to the memory. So from memory, what address register kept the instruction that is available in memory, that address register data transfer to instruction register, because instruction register keeps the only instruction. In that case what happens? That it transfer the data from memory transfer to instruction register. That means address register of instruction transfer to address register of instruction from memory transfer to instruction register. This is the basic concept in T1 time. In that time what happens? At you see at T0, PC the instruction transfer from PC to AR. The T1 time, that is already over. First T0 is over. T1 time, in that time what happens? PC just increasing, because that data, that instruction already transferred to instruction register. So PC increase, PC is equal to PC plus 1. So T1 time PC will be increase. And next T2 time, in this case you see T2 time what happens? The decode the opcode of operation, that is decode divide, that is D0, D1, D2 up to D7, and the decode part is there, decode part of instruction, and instruction is IR, IR means instruction register of particularly opcode part. Opcode part is 12 to 14. 12 to 14, that particular part, that is decode. Decode means since it is 12 part is 3 digit, 12 to 14 is 3 digits, so 2 to the power 3 is 8 opcode operation can be done, which need to that is a decode. So 8 means D0. If we go through D0, that is decoding of that data D0 to D7. Okay, that decode of data we will use in this manner. Other part is address register IR, address register transfer to AR, and mode is defined by I. So in this all part is done through T2 time. Okay, this all part is defined through T time. T time what happens is to decode the operation, decode operation in IR, and this particular this part, this opcode part is just decode, and at that time what happens? The address part transfer to AR. This you see transfer to AR, and mode part having last bit, that is 15th bit of instruction register transfer to mode, because mode is important to identify that is which reference we will consider. Okay, based on that execution also can be done. So this particular part is defined through D7. I have already told that is if D7 is equal to 1, then if D7 is 0, then memory reference, if it is 1, then what will do? Okay, so here this what I told in the previous this particular part, then that will be reflected through flowchart. Now we see D0 is 0, then we go through memory reference. If it D0 is 0 is go through memory reference, then identify actually data is accessed directly or indirectly. Okay, in that case what happens? Again that is depend on the I. If I is equal to 0, then go through direct data, direct accessing of data from memory. If I is equal to 0 in this case, if I is equal to 1, then what happens? Then indirect address. Okay, if we go through I is equal to 0, direct address, nothing to search, because direct data is there, operand is there, directly we can use. If indirect address, then we have to search in memory through address register. Again, whenever a number of address we will search where is our operand, then what happens? Through memory, address register through memory, we have to search it. After that, we will transfer the data from memory to address register. After getting that register, then start the execution. So after that, what happens? Execute through memory reference instruction. In that case, SE will be 0. This is the both either direct or indirect address through memory reference can be done for execution. You see, this is part will be over. Okay, if we go through memory reference, this part will be over. After that, what happens? Directly connect to this, again repeated number of times it is repeated. Okay, I can show you how it is repeated. Here very simple. Here go to, if you completed, then go to here and again that is repeated that part. This is the basic concept. Okay. Next, if D0 is 0, then we go through memory reference. If D0 is 1, okay, if D0 is 1, then two options are there. That is depend on the, that is a I. If I is equal to 0, D7 is 1. Again, two options are there. One option is register, another is input output reference. Then how to define that is input output reference or register reference? First we see it depend on the I. If I is equal to 0, then we go through register. You see, if I is equal to 0, then go through register. If I is equal to 1, then we go through input output reference. That means after getting D7 is equal to 1, again I is equal to 0, we go through only register reference. So execute through register reference instruction. Again it will lastly again transfer to this particular flow. Again it will repeat it if that is required. If I is equal to 1, then go through input output instruction. Okay, again execute that input output instruction. Then if it repeated, if it is necessary. So in this way, whole flow chart defined in this way. So you have to find out what kind of instruction need to execute and how it will start from T0 to T3. It is mentioned at T3 we will execute the different reference instruction, either maybe memory reference, it may be that is a register reference, or it may be input output instructions. So any instruction whenever we need to execute, we will decide that those reference which is depend on D7. If D7 value is 0 or 1, then we will decide which kind of reference we will consider. So different kind of reference, different kind of reference are defined through D7 only. Okay, this is the basic concept. You have to whenever we can or when we try to design this flow chart, then we will see that how it will design and how it will cover one after one as per the time slot. Means T0, T1, T2, T3 like this. Whenever T3 will get it, then execution will start, and that execution either go through memory reference or register reference or input output instruction reference. Okay, so this is the basic concept regarding on flow chart of instruction cycle. Okay, thanks to all to watch my videos. I hope all of you understand this particular topic. So I thank you very much. Please subscribe my channel, and if you want to give some comment, you can give comment and like our videos. Okay, thanks to all.